In a previous lecture, we considered the problem P equals 11 minus Q and CI equals 10 plus QI, where I represented up to two firms. We were asking the question, could a second firm with identical cost structure successfully compete with the first firm? In other words, can a firm who is not in the market contest this market? We concluded that it was possible that a second firm could contest the market, and in order for the first firm in the market to deter the second firm from entering, it had to set what is known as the limit price. It had to lower its price from the monopoly price down to some lower price level to make the market seem unattractive to the second firm. We determined that the first firm would set the price at the average cost when the firm has half of the market. So in this particular graphical analysis, using each firm's demand as half of the original industry demand, we would have the firm 1 set the price at P star, which turns out to be 3.764. If both firms were in the market, both firms would make a profit of 0. The second firm then would not enter the market if it considered that the market was not profitable, and the first firm would have the entire market to itself. So we would use the industry demand curve and the firm's average cost at that quantity, and we determined that the first firm would make a profit of 10, and the second firm would not enter. We're now going to consider two alternative scenarios. The first scenario would be a potential entrant, firm 2, with a higher fixed cost, and then the next scenario would be a potential entrant with a higher marginal cost. So we're going to first try the second firm having a cost C equals 12 plus Q, and then in the following scenario, firm 2 has a cost C equals 10 plus 2Q. Before we do that, however, we introduce the idea of a payoff matrix where firm 1 is the incumbent firm and firm 2 is considering entering the market. Even though in this table we say firm 2 shut down, we can substitute that with firm 2 not present, in which case we have 4 scenarios here for the two states of nature for firm 2 being either in the market or not in the market. Firm 1 has two alternative pricing strategies: the high price, the monopoly price of 6, or a low price, the entry deterrent price of 3.764. The payoff matrix contains the 4 entries for firm 1 when firm 2 is either present or absent, and we see that firm 1 will have what is called a dominant strategy because charging the high price will always yield more profits than charging the low price. We're going to circle the profit level that is higher for firm 1 under various states of nature for firm 2. So when firm 2 is not in the market, firm 1 would make a profit of 15 at the monopoly price of 6 and a profit of 10 at the entry deterrent price of 3.764. If both firms are present in the market, firm 1 with a high price will make a profit of 2.5, and with a low price, firm 1 would make a profit of 0. 2.5 is greater than 0, so if firm 2 is present, firm 1 should charge the high price. 15 is greater than 10, so if firm 1 is absent, firm 2 should charge the high price. Regardless then of whether firm 2 is present or absent, the data suggests that firm 1 is better off setting the high price. We call this a dominant strategy if under all states of nature for firm 2, firm 1 has the same strategy, and that would be in this case the high price. One thing it's important to note is that just because you have a dominant strategy doesn't mean that you would actually play that strategy. If it is a one-period game, then yes, the firm should play its dominant strategy. However, if it's a multi-period game, the firm should consider whether or not the high price will serve it best in the long run. It turns out that the entry deterrent price is best for firm 1 when firm 2 does not enter. So we're going to attempt to sketch the average cost curve for firm 2 when firm 2's cost structure is C equals 12 plus Q. The average cost for firm 2 would be AC equals 12 over Q plus 1, and when we sketch that curve, we would have the average cost intersecting the industry marginal revenue curve, which will be the demand curve for each of the two firms, at a quantity of 3 and a price of 5. There will be two intersection points. The higher price will not matter because the higher price will not deter entry. But the way to get to this particular answer is to solve the profit equals 0 equation for firm 2. There are two solutions there, and we want to go with the larger quantity, which would yield the entry deterrent price. In order to set the profit for firm 2 equal to 0, we set the revenue for firm 2 equal to the cost for firm 2. And since revenue is price times quantity, and total cost is average cost times quantity, we can reduce R2 equals C2 to P equals AC2, and then we can solve the particular set of equations, the demand equation, 11 minus 2Q, and the average cost, 12 over Q2 plus 1. Or we can solve it as revenue equals cost. It does not matter. In fact, revenue equals cost might be the easier way to solve the analysis, but graphically we want to be looking at the demand curve and the average cost curve. So we need to be comfortable floating between the two ideas, the graphical analysis and the profit analysis. Price equals average cost, or revenue equals cost, gives us 11Q minus 2Q squared equals 12 plus Q. And if we rearrange the terms, we get 2Q squared minus 10Q plus 12 equals 0. This actually can be divided through by 2, and we simplify to get Q squared minus 5Q plus 6 equals 0. So we have two numbers that multiply to give plus 6, but sum to give minus 5. And those two numbers, as we factor, we get Q minus 2 times Q minus 3 equals 0. Again, we're going to choose the larger quantity, which yields a lower price, the limit price. So we choose Q equals 3. We'll plug 3 into the firm's demand curve, and it has half of the market. So P equals 11 minus 2 times 3, or P equals 11 minus 6 equals 5. The price of 5 will be the entry deterrent price. So again, we said that at a price of 5, firm 2 will see the market as unattractive and choose not to enter, and firm 1 will then maximize its profit. In order to graphically see firm 1's profit, we need the average cost for firm 1, so please be careful that we know exactly what we're doing here. You would almost need two separate graphs, otherwise just calculate the profit. We know that firm 1 will have to set a price of 5. It will sell the entire market demand, which would be a quantity of 6, so the revenue will be 30. The cost for firm 1 will be C equals 10 plus Q. Q is 6, so C equals 16, and the profit would be 30 minus 16 equals 14. Let us now analyze using payoff matrix analysis the various states of nature for firm 2. As we had in the previous scenario, if the firm sets the high price, it can share the market and make a profit of 2.5, or it can be the only firm in the market and get the monopoly profits of 15. This is the first row, firm 1 setting the high price. We now need to consider the profits for firm 1 when firm 1 sets the low price. We just determined that if firm 2 is deterred, firm 1 will make a profit of 14. Now to figure out the profit that firm 1 will make if firm 2 is present, making 0 profit. We determined that the price was going to be 5 and the quantity would be 3, so the revenue is going to be 15 with a quantity of 3. The cost 10 plus 3 is 13, so the profit for firm 1 will be 2. We will conclude, as we did earlier, that a dominant strategy does exist, because regardless of what firm 2 is doing, firm 1 makes more profit with the high price than the low price. 15 is greater than 14, 2.5 is greater than 2. However, just because you have a dominant strategy doesn't mean you should play that strategy, especially in a repeated game scenario. And we conclude that firm 1 is best off in this scenario to go with the low price, the entry deterrent price of 5. Finally, let's consider a scenario where firm 2 has a higher marginal cost. Strictly speaking, the analysis is no different. It's the same analysis each time. However, you want to sketch the average cost curve to get a picture of what is going on. And I've included here the marginal cost for firm 2 at MC equals 2 to show you that the average cost curve would be even higher. Again, we want to determine the entry deterrent price that firm 1 should set so that firm 2 decides not to enter. Here's the analysis when firm 2 has a cost structure 10 plus 2Q equals C2. We determine that, again, the monopoly price when firm 1 is the only firm is the price of 6 and a profit of 15. If firm 1 wants to deter entry by firm 2, it must price so that firm 2 sees zero profit. So we have half of the market, 11 minus 2Q, equals the average cost, which will be 2 plus 10 over Q. And when we solve that, we come up with the quadratic equation. Using the quadratic formula, we get Q2 equals either 2 or 2.5. Again, we use minus b plus or minus the square root of b squared minus 4ac all over 2a. We determine to go with a larger quantity, 2.5, and that yields a price when you plug 2.5 back into the demand equation, a price of 6. So if firm 1 sets the price at 6, firm 2 should stay out because the market is unattractive to firm 2. And now we calculate the profit that firm 1 would make at a price of 6. It would be selling a quantity of 5, so the revenue will again be 30. The cost will be 10 plus 5 is 15, so the profit is going to be 15. Note that these answers are identical to the earlier scenario where firm 1 was the only game in town. So what we have here is a situation where by setting the monopoly price, firm 1 will actually deter entry. We can almost say that firm 1 then is acting in the setting of being a natural monopoly because under the current circumstances, firm 2 has no interest in entering